This is the Unit 1, Lesson 2 video, and in this video we're going to look at reviewing multiplying and dividing with fractions. So the first example here has kind of a visual representation of what we're doing when we're multiplying fractions. This says in the readathon, 4/5 of the participating students, so 4/5, collected pledge money, and 2/3 of these students raised $50. So 2/3 raised $50. So we want to find out what 2/3 of 4/5 is. And the word of in math always means to multiply. So we're going to kind of divide this up. If I divided this box down here into fifths, and I'm going to kind of highlight, color in 4 of these boxes. So 4/5 of the students, all of the sections that I'm coloring in yellow here, 4/5 of the students collected pledges for their readathon. Then 2/3 of those students, so I'm going to look here at the sections I've colored in yellow and divide this up and further highlight 2/3 of them. So if I now kind of break this up into, so looking at the students who collected pledges and dividing it up into 1, 2, 3 sections. If I highlight those sections, I'm going to highlight 2/3 of those sections, 2 out of those 3 sections. So there's 1 section there and 2 sections there. And those are the kids who collected at least $50. So let's count how many altogether this would be. Of the ones that are highlighted on both, it's 1, 2, 3, 4, 5, 6, 7, 8 sections. So there's 8 sections out of how many sections? If we make sections of the whole shape that are all the same size, I see I've got 5, 10, and 15 sections altogether. So 8 out of 15. So this kind of gives us a reminder of what the rule for multiplying fractions is. On the top, we've got a 4 and a 2, and we would multiply those to get 8. And on the bottom, we've got a 5 and a 3, and we would multiply those to get 15. So when we're multiplying fractions, we actually just multiply the 2 numerators together and multiply the 2 denominators together. And if we can reduce our fraction to lowest terms, then we should do that. So we'll do some examples here. Now this first example, I have 1/3 times 3/5. So if I follow that rule of multiply the numerators together and multiply the denominators together, I get 1 times 3 is 3 on top, and 3 times 5 is 15 on the bottom. Now that worked pretty well, but this fraction is not in lowest terms. So I would need to say, hey, what number divides evenly into 3 and 15? And that would be 3. So I'll reduce my fraction, divide top and bottom by 3, and I get 1/5. So that didn't work too badly. Multiply the tops, multiply the bottoms, and reduce. Sometimes, however, when we do that, this strategy in that order where we multiply and then reduce, we end up with really big numbers. So there's a way that we are going to look at to reduce, if possible, before we multiply our numbers together. And I like to use a different color for this. So normally we're looking at a numerator and looking at a denominator and saying what number divides evenly into both of these. And if you've got multiplication between fractions, this trick only works for multiplying. We can look at the numerator of one and the denominator of another and reduce from there. So I could have back here said, hey, I can do 3 divided by 3 and put an answer of 1. and 3 divided by 3 here and put an answer of 1. And then when I'm multiplying, on top I just have 1 times 1, which is 1. And on the bottom, I've got 1 times 5, which is 5. So I get the same answer both ways. The second way, I just reduce ahead of time before I multiply, which isn't a big deal with small numbers like this, but we're going to see in later examples where reducing ahead can help us really avoid getting some very big clunky numbers that we don't want to have to reduce in our fractions. So this next one is a good example of that. 5 over 21 times 14 over 25. If you multiply 5 times 14 and 21 times 25, you get really big numbers. And those fractions might be so big that you really don't want to have to reduce them. So we're going to look ahead and try and reduce ahead. So I want you to look at the numerator and the denominator of each fraction and say, is there something on the top and something on the bottom that I can divide evenly by the same number? And maybe you spot 5 and 25 and say, hey, you can divide each of those by 5. So I'm going to cross those two out and divide them by 5. I'm dividing by the same thing, top and bottom. So if 5 divided by 5 is 1 and 25 divided by 5 is 5. And you do need to show this step because that's your process work. I'm also going to take a look at the 14 and the 21. Can those be reduced? There is a common factor there. They both divide evenly by 7. So I'm going to cross those two out. 14 divided by 7 is 2. 21 divided by 7 is 3. So now we have much nicer, smaller numbers to work with. On the top, we're going to multiply the new numbers. 1 times 2 is a 2. And on the bottom, the new numbers, 3 times 5, much better than 21 times 25. 3 times 5 is 15. Same idea here. If you think you've got the hang of it, try pausing the video here and trying this one on your own before you watch the solution. So I think what a lot of people might see first is the 8 and the 16. So here I can reduce the 8 and reduce the 16, and I see that 8 goes into both of those. So 8 divided by 8 is 1, 16 divided by 8 is 2. If you don't find the biggest number that divides evenly, that's okay. It's still going to get it to be a little bit smaller. Like for instance, if you had divided those both by 4, you would just have a little bit of reducing to do at the end. Looking at the 35 and the 10, I can divide each of those ones by 5. So 10 divided by 5 is 2, 35 divided by 5 is 7. Now I'm going to multiply the numbers that are left. 1 times 2 on top is 2, and 7 times 2 on the bottom is 14. Now, it won't always, by doing this reducing, you won't always have your final answer in lowest terms, but it gets it a lot smaller because I didn't have to do 35 times 16. That would have been huge. But here I do see that I could reduce, both of these numbers are even, so I'm going to reduce that fraction. 2 over 14 is equal to 1 over 7. And our last example for multiplying, here we want to make sure that when we have a whole number, for instance that 6, we want to write it as a fraction. Any whole number can be written as a fraction by writing it over 1. So when I try to do my reducing, I see that 18 and 6 can both be divided evenly by 6. So I'd have a 1 and a 3. I'm going to now multiply 12 times 1 on top is 12, and 3 times 1 on the bottom is 3. And then again, sometimes you have a bit more reducing to do. That reduces to 4 over 1, or just 4. In this lesson, we're also going to look at dividing fractions. Here's another kind of visual example. This says Stanley has half a meter of birthday wrapping paper. So let's say that this is 1 meter in the picture. We could color in that Stanley has half a meter of wrapping paper. That's how much he's got. Each present he's wrapping takes 1/6 of a meter. So if we imagined dividing the whole meter of wrapping paper up into 6 sections like this, how many gifts could he wrap? Each present takes 1/6. So in the half a meter of wrapping paper that he has, he could wrap 1, 2, 3 gifts. Because 1/2 divided by 1/6 is 3. So we're going to look at the process of how that happens. And what you likely saw in grade 7 and 8 about dividing fractions is that when you're dividing fractions, you're going to need to multiply by the reciprocal. And reciprocal is just kind of a fancy math word for flipping the second fraction. So when we're dividing, we never actually do division. We just change it around. 3/4, we're going to flip the second fraction upside down and change it into a multiplication question. So we never do actual dividing in fractions. We just flip the second fraction and change it to a multiplication question. Now we're going to do our reducing just like we did in the previous examples. So here I have a 4 on the bottom and an 8 on the top. I can divide out a 4 from each. So that would give me 4 divided by 4 is 1 and 8 divided by 4 is 2. I can't reduce anything with the 3 and the 5. So now I'm just going to multiply. 3 times 2 on the top is 6, and 1 times 5 on the bottom is 5. It's okay to leave your fractions as improper fractions unless it's a word problem. Then you'll want to change it to a mixed number. Again, if you have a whole number, make it into a fraction by putting it over 1. Now we have 15/21. I change to multiply and I flip the second fraction upside down. I can reduce, dividing the 15 and 5 both by 5, so I get 3/1. And then there is a little bit more reducing, but here when I multiply, I get 3/21. And then I can just reduce my fraction, dividing top and bottom each by 3. So that final answer is 1/7. The homework that goes along with this is in your booklet, and there's just 2 questions, and each of them are just 4 multiplying questions and 4 division questions. So go back and watch the video while you're doing these if you get stuck. They're very, very similar to the examples we've done.